Hello everyone. Today we will be talking about metals and nonmetals. What are they? Before we talk about metals and nonmetals, let's have a recap from the last topic we have discussed. Let's talk about elements first. Science has come a long way since Aristotle's theory of air, water, fire, and earth. Scientists have identified 92 natural elements and created about 28 others. The most abundant element in the Earth's crust is oxygen. The periodic table of elements. It shows all known elements in the universe. Organizes the elements by chemical properties. The periodic table is an arrangement of the chemical elements organized on the basis of their atomic numbers, electron configurations, recurring chemical properties. Elements are presented in order of increasing atomic number. The standard form of the table consists of a grid of elements, with rows called periods and columns called groups. How do you read the periodic table? Its atomic number, symbol, name and atomic weight or mass. What is the atomic number? The number of protons found in the nucleus of an atom or the number of electrons surrounding the nucleus of an atom. What is the symbol? An abbreviation of the element name. What is the atomic mass? It is the number of protons and neutrons in the nucleus of an atom. The elements of the periodic table can be divided into three main categories: metals, nonmetals, and metalloids. Now let us talk about metals and nonmetals. Metals. Majority elements in the periodic table are metals. This includes alkali metals, transition metals, lanthanides, actinides and alkaline earth metals. Metals are separated by known metals on a periodic table through a zigzag line starting from carbon till radon. Nonmetals. Very few elements in the periodic table are nonmetals. These are present on the right-hand side in the periodic table. Elements that come under nonmetals are sulfur, carbon, all halogens, phosphorus, hydrogen, oxygen, selenium, nitrogen and noble gases. Physical properties of metals and nonmetals. Metals. Are shiny. Has high melting points. Good conductors of electricity and heat. Has high density. Malleable and ductile. Nonmetals. Dull. Low melting points. Poor conductors of electricity and heat. Has a low density. And it is brittle. Some elements have properties that are not typical. For example, mercury, a metal, has a low melting point and exists as a liquid at room temperature. Graphite. A form of carbon, a nonmetal, has a high boiling point and is also a good conductor of electricity. Metals and nonmetals can also be distinguished by some chemical properties. The most common chemical property is the type of oxide that the element forms. Metals form oxides that are basic, but nonmetals form oxides that are acidic. For example, sulfur and carbon are both nonmetals. They react with oxygen to form sulfur dioxide and carbon dioxide. These compounds are both gases present in the air and which dissolve in rainwater, making it acidic. Uses of metals and nonmetals. Metals are used in making machinery, airplanes, automobiles, trains, satellites, industrial gadgets, cooking utensils, water boilers, etc. Nonmetals are used in fertilizers to improve the growth of plants. Nonmetals are used in water purification. METALLIODS. Metalloids are a small group of elements found in the periodic table of elements along the zigzag line that distinguishes metals from nonmetals and is drawn from between boron and aluminium to the border polonium and astatine. Properties of metalloids. Metalloids have properties that are intermediate between metals and nonmetals. They have properties that are difficult to characterize. Following are the elements that are considered to be metalloids: boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Physical properties of metalloids. State of matter is solid. It has metallic luster. It is brittle and is semiconductive in nature. Chemical properties of metalloids. They are capable of forming glasses. When mixed with metals, they form alloys. Metallic and non-metallic allotropes are formed. Few metalloids contract when they are melted. Compounds are formed when they react with halogens. Common properties of metalloids. Metalloids are good semiconductors. The reactivity of metalloids is dependent on the properties of the elements they are reacting with. Electronegativity and ionization energy are between metals and nonmetals. Uses of metalloids. Boron is used in fireworks as it has the quality of changing color into green when it is burnt. It is one of the most explosive metalloids. It is used in the form of boric acid and can be used as a cleaning agent. Silicon finds application in the computer chips as it is a semiconductor. Silicon in silicones can be used as a waterproof sealant on roofs, around water pipes. It is used in semiconductor industries to improve conductive properties. Fluorescent lamps and infrared detectors use germanium. Antimony is used as one of the ingredients in paints and ceramic enamels. In ancient times, Egyptians used antimony as a cosmetic. When arsenic is mixed with gallium, it can be used as a semiconductor and finds application in LEDs. It is so toxic that arsenic can be used as an insecticide and in the preservation of wood. Tellurium. It is used as an additive in the creation of alloys, and used in the making of cast iron and ceramics to prevent thermal shocks. Polonium. Polonium has no use as it is the rarest element and is highly radioactive and toxic in nature. Thank you for watching.